Hey everybody, what's going on? My name is Jeff, and I wanted to shoot a quick video here. Excuse me, for some tools. I talked about some tools that help me pass my CCNA and my CCNP, and it's helping me currently as I pursue my CCIE for routing and switching. So one of the tools that I have here is GNS3. GNS3 is a freeware that allows you to emulate layer 3 technology and some layer 2 technology, some switching. I actually have a lab in my house, a 20 router infrastructure, all virtualized. But when you're starting off, of course, the cost, excuse me, the cost is something that is going to be a factor. This is one of the solutions that I used, and I thought that was really, really helpful to help me understand what I was reading and apply the actual technology and apply the discipline. So what I wanted to show you real quick was some of the cool features of GNS3, and then if this is something that you think that will be useful for you, I drop my email in the Facebook post, so then you can go ahead and just shoot me an email, and then I can walk you through separately on how to configure this setup, and then get you rocking. So, excuse me. First things first. So I have a 4 router infrastructure here, and I just want to show you pretty much the power of GNS3. So we're going to work all on layer 3 in this video. And as you see, I got some devices here. I also have some layer 3 switches. These are not Cisco devices. These are Arista virtualized switches. They do pretty much a 95% job for learning layer 2 technology. The only thing that you can't learn on the Arista switch is Cisco proprietary protocols. And that's pretty much, Cisco proprietary is pretty much gone out the way. Everything's just becoming a regular standard. So I will show you how to configure all of that in a separate video. But what I wanted to show you is, let's get that out the way, our infrastructure here. So I had tried to record a video earlier, but my nieces and family came over and it was extremely noisy. So I just want to start fresh again. So what I did was here is I configured, I just want to show you this. Oh, it's up there. I'm sorry. I configured this just simple 4 router network. And what I did was, for the link, I used the prefix 155.1 xx.y. X representing the router numbers combined. So router 1, router 2 would be 1, 2. And then Y would be the actual router, so 1. So this interface fast Ethernet 00 will be 155.1.1.2.1. And then on this side would be the same, but .2. And then for the loopbacks, I did 150.1.y.y for the router. So for this loopback on router 1 would be 151.1.1. And I got the subnet mask up there, CIDR of 24 and a CIDR of 32. If you are starting off your CCNA journey and you look at this and you're like, what the hell is that? There is this sheet, and let me pull it up real quick. There's this sheet that I used from this website, and it's a really good tool to help you understand the subnet, because you're definitely going to need to understand subnetting. IPv4 is kind of, we know we're out of IPv4 addresses and we're starting to slowly migrate to IPv6. It's still going to be relevant on the exams that you take now, but this cheat sheet here, and it's down. Now you can see there's a gang of these, and I'll show you IGPs, BGP, EIGRP, all the different routing protocols, and then there's access list common ports, this subnetting. So when you see that, when you see a WAC 32, it means the same thing as 255, 255, 255.0. Excuse me, 255. And I will make a separate video on subnetting. If you want, just drop a comment in the box and let me know. But I have a really, really, really good way of teaching subnetting. I actually learned it in ANA, and it stuck. When I tried to learn it in JNC or NSVT, it didn't stick. But when I went to ANA, I don't know what the hell the teacher said, but it stuck to me really well, and now I want to give that skill to you. So enough about that. We'll get back to the infrastructure. So I'm on a Mac. This GNS3 works on a Mac and a PC, and I believe it works on Ubuntu if you're running that. But most people probably either run Mac or PC. To configure the routers, I have my terminal, and let me actually just close this so you can see how it looks when you open up all of them. So you just right click on the router, and you're gonna go to console, and you'll build a console in. So I'm just open up a console for all of these, for router 2, router 4, and for router 3. So I'll mute that. I'll mute that for you so you don't have to hear that. Now, if you have all these windows up here, it's kind of annoying because you can't really see what's going on back here. So on Mac, you just go here to Window under Terminal and merge all windows, and it'll put it in a nice little box for you so you can see what you're doing. I personally like to just put these in order. That way I could just go router 1, router 2, router 3, router 4. It's your preference. I also have another program called Secure CRT, and this one is really cool. You can actually, let me put that back over here. Actually do the same thing. So I can go and open up routers 1 through 4. And it'll open up exactly the same thing that I have in the background. I'll tell you more about Secure CRT in another video, but it's a really, really cool tool, especially when you start configuring more and more routers, which you will after going through this video, because you're going to become a routing genius. Because your infrastructure is just going to get bigger, and this should be real. 4 routers is a very small infrastructure. 20 routers is a very small infrastructure. You will be able to manage hundreds of routers. I didn't believe it before when I first started, but now it's just, you don't even see, it's like the Matrix, I guess. You just see the lines, you know what to configure, because you understand how routing and switching works on the underlay. You don't even care how many devices there are, you can still configure it. But enough about that. So what I've already done is I've already configured the devices with the IP address, and I just want to go over it real quick, what I did. So show IP interface brief pipe exclude unassigned. So what I did was on Fast Ethernet 00, which is this link here, I gave it the IP address of 155.1.12. The third octet represents the links between the routers, and then the fourth octet 1 represents the actual router. So that's going to be .1 for this interface. On the loopback, I also did 150.1.1.1, and this represents the loopback of the actual router. And you'll see why I did that, because when we're learning, we need to just be able to physically see something. To me, that's how I learn. I think when I explain it, and you'll see, you'll be like, oh, okay, that makes sense, on why I did it this way, and this is the way that I was taught, to just help you recognize stuff visually when you're looking at it. Because when you get out into the real world and you're configuring IPs on a real network or in production, it's going to be, of course, the IP address is not going to be like that. You're going to have a wild IP addressing scheme, but you'll already understand the underlay. So I'll just run this command, and this command that I ran up there is show IP interface brief. And if you put the pipe, which is the output modifiers, and I put exclude unassigned, I don't know if it's going to actually let me do it. I don't know if it's going to actually let me do the actual unassigned. But if you put unass, which is unassigned, it'll show you all the interfaces that are up that are actually assigned, because I do not want to see the other ones. So if I did a show IP interface brief, you're going to see all these other interfaces that you don't want to see. So to clean it up, I run that command, which is the unassigned. So I'm going to run that command on all the devices just so you can see the IP addressing. So again, on Fast Ethernet 00, which is this link on router 2, we just did the opposite, or the other side, 155.1.1.2 for the network in between, and 2 for the actual host here on this side. We did the same thing across the link on 01, which is this link here, 155.1.24.2, representing router 2. So you can already guess what this side is going to be, right? 155.1.24.4, right? And what we did was we changed the IP scheme to go between here, between routers 2 and 3. We changed it to 160, which is fine. But we did the same thing, 160.1.23.2, and then it'll be 23.1 on this interface. It should be 23.3, that's right. And then same thing for the loopback, 151.2.2. So I'm just going to show you real quick. I don't know why I keep on show IP interface brief. Pipe exclude on the side. So same thing here, 161.23.3, 151.3.3, and then in router 4. Don't ask me why I keep trying to type that command right there. I'm trying to do something that I'm going to do later in the video. That's why I keep trying to type it. So I want to show IP interface brief, pipe exclude unassigned. All right, so all IPs are set. So now what I want to do is I want to do a routing protocol. So you can see that I have up here, I have EIGRP 100 that I want to run in between routers 1, 2, and 4. So to do that, we're going to start on router 1. We're going to go into global config. And then we're going to go router. And then here's where you can run all the different routing protocols, BGP. I'll do a separate video to explain like each individual routing protocol, but I'll just give you a brief one as I go down. BGP Border Gateway Protocol is really not a routing protocol, it's an application layer. It's run at layer 7 and needs IGP, which is your interior gateway protocols, and I'll explain what that means, but it's transport on top. EIGRP is an IGP, which is an interior gateway protocol. This is a Cisco proprietary protocol, which means it's only going to work with Cisco devices. ISIS, not to be confused with ISIS, which ISIS was there before ISIS was, another topic, is another routing protocol. This is making a comeback. It actually was actually used way a long time ago, but now it's making a comeback in what's called a fabric path, which is for the layer 2 transport for data center. But I'll talk about that. This is just I don't know why this is not even a protocol, IGRP. This IGRP is the old protocol. EIGRP is the new one, but I'm running on an older code in the GNS3 mobile. On-demand stub routes, I'll talk about that later. That's a little bit more advanced. OSPF, Open Shortest Path First, is a open standards protocol. This is probably one of the easiest and hardest at the same time protocols to run. And then RIP. RIP comes in RIP version 1, RIP version 2, and then RIP next generation, which is RIP for IPv6. Same thing for OSPF. There's OSPF, the current version is 2, and then there's OSPF version 3, which runs both AFIs, which is the address family of IPv4 and IPv6. Okay. So we're going to run router EIGRP. So I got on my soapbox. And then we're going to run the autonomous system number, which is going to be 100. Now, when we run the protocol, we want to advertise the networks. So if I do show IP interface brief, exclude unassigned. So the network that we want to broadcast is this network, not this actual address, but the network of this address. So we're going to do network 150.1.0.0. That's our network address. And same thing for 155. Now I'm on an older code, so I always just put no auto summary. In the new code in 15 code, you should be able to, no auto summary will be in there automatically, and we're done. So now we need to put that, what I just did. See, this is what I was trying to do earlier when I kept typing it. We need to put this EIGRP on all the routers that we want to run EIGRP on. So copy and paste is your best friend. All I'm going to do is take this same router configuration, copy it, and I'm going to take it to router 2. I'm going to go back in the global config, and I'm going to paste it, and I'm done. And you see this message that came up here. Neighbor change EIGRP on fast Ethernet 155.1.12.1. I got a new adjacency. I'm going to do it on router 4 as well. And I should get the same thing, new adjacency up. So EIGRP is done. That's it. That's all you got to do to put EIGRP across 1, 2, and 4. And to verify, let's just do some quick verification. We're going to do a show IP route EIGRP. And now we have routes all the way across, right? And I want to do it on all the routers. And actually, let's do show IP route first, just to throw that whole routing table in there. So we can see here that we know about this route here, 155.1.24. That's the link between here and here. And we know about 155.1. Let me just check something real quick. Okay, perfect. So now let's configure RIP version 2 between routers 2 and routers 3. So we're going to go over to router 2. We're going to go config T, go to router RIP. And since this is RIP version 2, we're going to do version 1 or 2. We're going to do 2. And we're going to broadcast the network that we want to RIP across to. And it's going to be network 160. And we're going to do the same thing. We're going to do a show run pipe section RIP. So this is going to look, when you do a show run, so when we do a regular show run, right, we see the whole running config. But if I don't want to wait and look at all this stuff, right, I could just say show run. And the section I specifically want is the RIP section. So I just want this portion. So I'm going to take this and I'm going to drop that on router 3 as well. So now let's just see what we got so far. So let's go to router 2, since router 2 is our central point. Let's go show IP route. And we should have a route between 2 and 4 is going to be connected, right? And 1 and 2 is going to be connected. Okay, and this is IP route. So now we got our networks connected. And I forgot to put the no auto summary here. So let me go back real quick. EIGRP. Let me just double check that. Make sure we had that for all of them. Okay, there we go. Let me just copy that. I just want to show IP route. Make sure we got all our routes in there. Okay, so I need to redrop that. I forgot to put that on there, my bad. And what the no auto summary means is that it doesn't go to the classful boundary. So it makes because usually you're gonna have, let's say for example, you have a 192.168 network. That's usually a class C private network. So that would be the boundary. It would automatically assume that the subnet is 24. But for a 150 is technically in a class B range, which would be 255.255. So we made the subnet, though, we made the subnet 24. So that's outside of the class. So this removes that, and you don't have to worry about it being in the classful boundary. Now if we do on router 2, let's just show IP route. Now I have a route to router 1's loopback, router 2's loopback, or excuse me, which is directly connected. I have a route to router 4's loopback, but you notice I don't have a route to where? To router 3. And if we can test this, we could test our EIGRP connectivity by doing this. We could go to the end of the network on this side, router 4, and we could do a trace to 151.1.1 and see we can get there. So we can get there via 24.2, which is this link here. We're going to pass across, and then we're going to go to the next hop, which is 121, and then we're at the link. We're at 151.1.1. Also, just ping it, right? Boom. So we're good. So on router 2, we can't see okay, perfect. We need to also advertise. I didn't advertise it in here, but we also need to advertise router 3's loopback. So we need to go back in there and go router rip version 2 and do network 150.1.0.0. So now, see how we had in this routing table, we didn't have router 3 because we only had router 1, we're router 2, and we had router 4. Now if we do a show IP route, now we have router 3. So since router 2 is a centralized point of the network, it's learning about routes EIGRP from both this link and this link, but it's also learning about routes from RIP via this link. So the question is how do I get from router 3 to router 1? So if I'm on router 3 right now, technically ping 151.1.1, it shouldn't work. And the reason why is there is no valid route to the host because it doesn't know how to get there. And how you can see if the router knows how to get there is through the routing table, which is called the RIB. And the routing table is when you do a show IP route. So that shows you all the routes it knows about. But to be specific, if you want to say specifically, do you have a route to a specific network? You can do show IP route and then actually put the network that you're trying to reach. So see, 7.9 in table, that says, hey, we don't have a route there. I can also do show IP ceph. This is the forwarding table or the fib for 151.1.1. It's going to say, we don't know how to get there. Now we could fix that with what's called redistribution. And router 2 is going to be our redistribution point because that's the point where both routing protocols interject. And it's very, very easy to do. So what we're going to do is we're going to start with EIGRP. So we're going to go back into global config. We're going to go router EIGRP 100. And what we're going to do is we're going to redistribute RIP. And we're going to make a metric of the standard EIGRP metric, which is 10,000, 10,010, 255. And what I'm going to do is show you this. So this first number is going to be the bandwidth. So the link of the bandwidth. So 100 meg, or excuse me, 1 meg, 10 meg, 100 meg, or gig, 40 gig, 100 gig, whatever you have in there. So for this, since it's fast Ethernet, it's 1 gig or 100 megs. We'll do this is in kilobits. Then we'll go and we'll do the delay, which is 10 microseconds. The reliability 255 because it's the link is open. The load, we don't have a load, so we'll put the lowest one, which is the default, and then the MTU, which is 1500. And we're done redistributing RIP into EIGRP. So you start on a protocol that you want, then you redistribute. You're going to redistribute RIP. Now we're going to just go the other way. We're going to go into RIP, and we're going to redistribute EIGRP, and then we're going to say what autonomous system number, that's 100. And we're going to do the metric, and we're just going to do a hop count of 1. So metric, when we start talking about the different routing protocols, each routing protocol has a different way of measuring the administrative distance, and the metric, that's the calculation that it does. Each routing protocol has a different one, and we'll break down each individual routing protocol. That's going to be huge for the test. But just to show you functionality for GNS3 first, I'm just showing you how to do it. Now we have redistributed everything everywhere. So the routing protocol is going to redistribute what? 2 is going to redistribute EIGRP routes into RIP, and then 2 is also going to redistribute RIP routes into EIGRP. So now we should have a full mesh. We should be able to see routes from everywhere. And the best place to go to see the routes is going to be router 3. So we started, this was router 3's routing table, or fib, or excuse me, a rib. So now what we're going to do is we're going to do another show IP route. And now what we should be able to do is we should be able to see all the different loopbacks. So now we can see router 1's loopback, router 2's loopback, router 3, that's us, and router 4. So now all we have to do is just, hey, let's ping over, let's do a trace. So let's trace to 151.4.4. So we should hit on 23.2 and then 24.4. So 23.2 was the first hop, and then 24.4 was the second hop. And the way I found that out was you're going to go from here to here. This is the first hop. And then the next hop is going to be this interface here. So we should be able to ping that as well. Bam. And the same thing is going to be true across all the devices. Show IP route. So we see we got 1, 2, 3, and then 4. Same thing here. And then of course on router 2, since they are the hub, all of them. So you can see in here, let me make this just a little bit bigger. Actually, let's go to router 4. So you can see in here that it knows it redistributed that RIP route, which came from router 3, as an EIGRP external route. And the way that you can quickly see that, this is kind of like, if I was building a test, I would make a test question. I would say which routes, according to this routing table, which routes are EIGRP external routes. And I wouldn't show you this section, where, or excuse me, this section where the D's are. I would just show you the IPs, and I would show you kind of like, I don't know if I can do it. It probably won't let me do it. Nope. I would just show you like that section, if that makes sense, to where you could just see only the IPs, the administrative distance, and the metric. So looking at this, 170 pops out like a big, huge, like, hey, I'm EIGRP external route, right? And how we know that, we see the EX for EIGRP external, but we also know that it's an administrative distance of 170. So that's the things that you need to remember for the test. Like 90 spits out as EIGRP. Rip, when you see a rip route, you should see 120. You should already know that's a rip route. If you see a route for 110, you should know that's OSPF. Like as you get more and more and more familiar with the lab or labbing and building networks, those things will just start popping out to you. 115 is for ISIS. Those things will just pop out. Those are things that you need to know for the test. Those are some of the things that you need to know for the test. But I just want to make this quick video to show you the functionality. If you got specific questions, or if you want me to build you a lab, or you want to troubleshoot, depending on where you're at your studies, do you want to go back to the groundwork and like, I still don't understand when you typed in this /32, what the hell does that mean? Or what does 24 mean? You just let me know where we need to start, and we will go from there. But this is a really, really, really powerful tool to use for your training. I will show you my lab. Let me see if I can pull up a picture. And what I did was, after a while, I needed more space. I actually needed more routers because this laptop has 16 gigs. So I ended up buying a server. This is actually my CCIE rack. And this is an old picture, but I have a server that runs 20 virtual routers inside. Then I have my switch stack here with my 4 switches. And then I also have my 4 routers. These routers are for anybody who wants to get in and console in. You just got to give me a call, or shoot me an email, and I can let you console in. I'll build you up something so you can go around there and play around. But you don't even really need that, honestly, because once you get this up and running, GNS3, you can build anything. You can build whatever you want, and if the sky's the limit. The sky's the limit, really, because it's really the limit is on your RAM. I'll take that back. The limit is on your RAM. Even if you don't have a lot of RAM on your computer, to get the basic concepts down, you need probably about 3 routers. When you start getting into more CCNP, and then going up into your CCIE for traffic engineering, you want to start doing some BGP stuff. You will need a little. It's better to have more routers, but the basics for CCNA, this will do it. And for your switching, you can get these virtual switches. These, like I said, are not Cisco. These are not Cisco switches. These are Arista. So the Cisco proprietary protocol stuff that you need to run won't show up, but they do the job as far as finding out what you need to do. And these symbols, know those symbols, because those are going to be testable. Those are standards. Like I said, I just want to show you quick what the power of GNS3 is. Whichever direction you want me to go out, just drop me a line and let me know specifically which way you want to go, and then I'm here to lab it up. I'm here to do videos. So if you got a question, I'll try to lab it up. I'm a CCIE candidate, not a CCIE yet, but I will do the research and the grunt work for you. And then, helping you helps me, helps me practice. So I'm here. So yeah, if you have any questions, shoot me up or hit me up. But besides that, thanks for watching.